Hi everyone, in this recording we'll be going over the complex plane. Our goal is that by the end of this presentation you'll be able to plot complex numbers in the complex plane and find absolute values of complex numbers, that you'll be able to perform operations with complex numbers, and be able to use the distance and midpoint formulas in the complex plane. So we already learned how to represent real numbers by a point on the real number line. In this section we will learn how to represent a complex number where z is equal to its real portion plus its imaginary portion, so a plus bi, by a point a comma b in a complex plane known as a coordinate plane. So in the complex plane, the horizontal axis, this one right here, is known as our real axis, and the vertical axis right here is known as our imaginary axis. So the absolute value of a complex number, z is equal to a plus bi, is the distance between the origin 0, 0 and the point AB. So we said that this part was this axis was our real and the vertical axis was our imaginary. So if we're given the point A comma B, where A is the real portion and B is the imaginary portion, then the distance between that point and the origin right here is given by this formula right here. So we will take the square root of a squared plus b squared, and that is the absolute value. So if the complex number is real, so when b is equal to 0, then the definition agrees that with that given for the absolute value of a real number. So if we have any number that is real, that means it'll be on the horizontal axis because it'll have an a portion, but the b portion, the imaginary, will be 0. So then we can just take the absolute value from 0 to that point A. Here we're told to find the absolute value of the complex number z is equal to 3 plus 4i. So first we can determine the real and the imaginary part. So we have 3 in the real portion, so right here. So this will be the point 3 for the real. And then for the imaginary part, we have 4 right here. So 3 comma 4. Now we stated that the absolute value was equal to the square root of a squared plus b squared. So we will take the square root of 3 squared plus 4 squared. So 3 squared is 9 and 4 squared is 16. So 9 plus 16 is equal to 25, and the square root of 25 is equal to 5. So that means that the absolute value, this portion right here, is equal to 5. So in previous recordings, you learned how to add and subtract vectors geometrically in the coordinate plane. So similarly, we can add and subtract complex numbers geometrically in the complex plane. So first, you can represent your complex number in the vector form with the components a and b. And then to add two complex numbers, you can represent the other one in its vector form, and then you can add their components. So here we're given the two complex numbers. z1 is equal to 2 plus i, and z2 is equal to 1 plus 3i. So in vector form, we can write this one as 2 comma 1, where 2 is the real portion and 1 is the imaginary. Here we have 1 comma 3, where 1 is the real portion and 3 is the imaginary. So now in order to add, we just add each of the components. So 2 plus 1 is equal to 3 for our real portion, and then 1 plus 3 will give us 4 for our imaginary portion. So that means that the sum of these two imaginary or complex numbers give us this complex number, 3 plus 4i. Now the distance between 2 points in the complex plane is the absolute value, or the modulus, of the difference of the two corresponding complex numbers. So if we're given the point a comma b and the point c comma d, where a and c are the real portions and b and d are the imaginary portions, then we can take the difference between the real portion, so c minus a, and then the difference between the imaginary portion, d minus b. Then we can square each of those portions and add them and take the square root to find our distance. So the distance is equal to the square root of c minus a squared plus d minus b squared. And a and b, or a comma b, is the first point and c comma d is the second point. Now to find the midpoint of the line segment that joins 2 points in the complex plane, we can find the average values of the respective coordinates of the two endpoints. So if we're given the initial point a comma b and the terminal point c comma d, or the last point, Then we can take the averages of each of the respective portions. So a plus c divided by 2 and b plus d divided by 2 will give us the point in the middle of those 2 points, or the midpoint. In this example, we're told to find the distance between the two imaginary numbers z1 is equal to 1 plus 2i and z2 is equal to 4 plus 6i. So first we subtract the real portions, so 4 minus 1 is equal to 3. Then we can subtract the imaginary portions, so 6 minus 2 is equal to 4. So then, using the Pythagorean theorem to acquire the distance, we take the square root of 3 squared plus 4 squared. So 3 squared is 9 and 4 squared is 16, so 9 plus 16 is equal to 25, and the square root of 25 is equal to 5. Here we're finding the midpoint between two of these complex numbers. So for the first point, we're given the point 2, 2. 2 is the real portion, and the other 2 is the imaginary point right here. And then for the second point, we're given 6, 6. So the imaginary and the real part are both equal to 6. So first we find the average in the horizontal portion. So we do 2 plus 6 divided by 2. So 2 plus 6 is 8 divided by 2 will give us 4. And we'll get the same for the vertical component since they are the same numbers. So then the midpoint is at the point 4, 4.